Hello, my name is Robert Smith and I'm with New River Community College's Academic Assistance, and today we are looking at concentration of solutions. Our first problem asks how many grams of hydrochloric acid are required to prepare a 350 milliliter solution whose concentration is 1.62 molar. The first thing we're going to want to do is convert this milliliters to liters, and you'll see why in a minute. So in order to do that, we're just going to say 350 milliliters times 1 liter for every 1,000 milliliters is equal to 0.350 liters. Milliliters and milliliters cancel each other out in that process. So now we have a unit of volume that is reflective of liters, and we need to figure out how to find out how many grams of hydrochloric acid are needed to prepare the solution of that volume with the desired molar concentration. So in order to do that, we need to look at our equation for molarity, which is molarity is equal to the number of moles per volume, and the volume has to be in liters. But we have the molarity and we have the volume. What we need is the moles. So if you multiply V to both sides, volume to both sides, you find that moles can be calculated by multiplying molarity by volume, which in this case would be 1.62, and you can change that capital M to moles per liter, which is most useful when dealing with dimensional analysis, times the number of liters that we calculated, which is 0.350 liters. You find that liters and liters cancel each other out, and you're left with moles, which is exactly what we wanted. And when you do the arithmetic out, you find that we are getting 0.567 moles. So we need 0.567 moles of hydrochloric acid in order to create the desired concentration using the desired volume. So in order to calculate exactly how much of the mass of the hydrochloric acid, we need to first figure out how we're going to convert our moles to grams. Well, in order to do that, we're going to need our molecular mass of hydrochloric acid, which, if you do that calculation out, is equal to 1.008 grams per mole plus 35.45 grams per mole, which is equal to 36.46 grams per mole. Then solving for mass is relatively easy. All we have to do is say that mass is equal to our moles times our molar mass, which in this case is a molecular mass. So 0.567 moles times 36.46 grams per mole, which equals 20.0 0.7 grams. 3 significant figures because our moles had 3 significant figures. And that is our mass that is needed in order to produce the molarity desired given the volume acquired. Our next problem asks us to calculate the volume required for a solution whose concentration is 3.25 molarity and has a solute, which in this case is sodium chloride, mass of 8.31 grams. In order to do this, we're going to want to first start by calculating the molecular mass of sodium chloride. And if you look at your periodic table, you find that sodium is 22.99 grams per mole. And to that, we're going to add the molar mass of chlorine, which is 35.45 grams per mole, which gives us 58.44 grams per mole. That's its molecular mass. We are given the mass in this instance. What it's asking for is volume. We know that the equation for molarity includes moles and liters. So, given that information and given that we have the mass, we calculated this molecular mass in order to use it to manipulate the mass of the solute to give us the moles of the solute, which in turn will be used for our molarity calculation. So, we can then take and solve for moles, which is what we need in order to find the missing value, which is volume. So, we have 8.31 grams. Start with your given, and then multiply it by 1 mole over 58.44 grams. Simply a manipulation of the molecular mass. You find that grams and grams cancel each other out, and you're left with moles, which is exactly what we want. And when you do the arithmetic out, you will find that you end up with 0.142 moles of NaCl. That's how many moles of NaCl are in 8.31 grams of NaCl. So now that we have the molarity and the moles, we can calculate for the volume. Recall that molarity is equal to moles per volume. If we solve for volume, we would find that you multiply volume to both sides and then divide molarity from both sides, and you end up getting volume is equal to moles per molarity, moles over molarity. So therefore, we find that the volume is equal to 0.142 moles over the molarity that's given, 3.25. And in this case, we're going to write out the units, moles per liter. Moles and moles cancel each other out. Liters jump to the top. Do the arithmetic out, and you can determine that 0.0437 liters are produced in this process. We can then convert that, if we desire to milliliters or some other unit of volume. But it doesn't ask for it, so we're just going to keep it in liters.